Welcome to lesson 4 of chapter 8, Advanced Enum. So far in this course, you've only interacted with protocol with classes and structs. Today, let's learn how enums can confirm to protocol as well. By the end of this lesson, you will learn how to create a simple game design. You'll also get a taste of creating your own custom operator in the Swift programming language. Let's begin the lesson. Welcome to Learn Swift About. Today, let's talk about how to combine protocol along with enum. So if you remember correctly, enum is nothing more than providing a blueprint, just like structs and classes, right? But protocol is like a basketball coach telling enums and classes. So protocol is like at the right here, enums right here, structs are right here, and also classes are right here. So protocol tells the classes and enums what to do about this, okay? So protocol provides a little more rules to follow, okay? Let's go. So in this case, we're gonna learn how to design a game using enum, and we're gonna follow this certain protocol. There's a protocol called lifespan, okay, and it contains a number of hearts, and it's gonna be get. Again, if you remember the rule back in chapter 2, if it's get set, when you're making a computer property, you have to make it gettable, settable. If you make it as a get, you can use both, either settable or gettable. You can do both, right? And then we have a two method available. Mutating method, increase the heart, get attacked, okay? Well, if you see the word mutating, that means you're interacting with a case later down the road, okay? So let's see what's happening. So first of all, let's design an enum, and we're gonna have two cases available, which is case dead, okay? The player could be dead, or it could be alive. Okay, but when you're alive, it does contain number of hearts, right? You could have 1 heart, 2 heart, 3 hearts. Sounds good. And then it's going to complain to you, well, because it does not conform to the lifespan protocol. So we have to have this protocol that we need to implement this protocol. The coach, the basketball coach, is telling us what to do right now, right? So we're going to follow them. So for now, just leave it like this to get rid of the error message, and we should be good. Oh, we are now implementing number of hearts, so we also have to implement number of hearts. So I'm just gonna copy and paste this. We're gonna make a gettable property of number of hearts. Okay, right there. We're gonna make a gettable property, and the number of hearts is gonna be based on whether the player is dead or alive. If it's dead, you're gonna have 0 number of hearts. If it's alive, it's gonna have associated value of current heart. So you know what to use right now, right? Again, I'm gonna give you 3 seconds to answer. 3, 2, 1. Okay, you told me right. We're gonna use a switch statement. Switch self, right? Self refers to the current object right there. So we're gonna have switch self, and here we go. We have switch self. If it's dead, it's gonna just return 0. If it's alive, okay, case let. Again, the let is used to get the value of the associated value. So alive number of hearts. You can just call it number of hearts and return it right there. Okay, so let's test it out. So you have let's say we have a state player dead, and then what was it called? If you try to get the value of number of hearts, it's gonna return 0, right? But if it's alive, and then you enter some sort of a lot of big number right there, it's gonna give you. I think you have to have that parameter, the name right there, and then the number of hearts. You're gonna have a lot of number of hearts available to you. Okay, all good, right? All good. So, but we're gonna have this. What do you call that? Increase heart and also get attack method associated. So that means if it's dead, all right, if you increase heart, you want to make it alive and also have a current heart of 1. And if you get attacked, if it's alive and current heart is 100, it's gonna be 99. But if it's at 1, you're gonna be dead, all right, and then become 0. So let's implement that method for us, custom method. So here we go. We have increase heart method here. We're gonna use you know what to use. You always use a switch statement, or you like to use switch statement when it comes to enums. So what is the self here? Self is the object. If the case is dead, okay, and the self becomes alive, and it contains current heart, becomes 1. Okay, it becomes alive. Okay, there was a problem here, right there, boom. And if it's case let alive, right? Because this is what do you call that? Associative value. So alive, and then current becomes the current number of hearts plus 1. Default, we'd only default because we covered the entire case in this entire case. There are only 2 cases available, which is dead or alive. So again, let's recap just one more time. Number of hearts, case let number of hearts. So we have a switch statement. So if it's dead, then if you call this method, you're gonna increase it. You're gonna make it alive first of all. You're gonna convert it from dead to alive. You're interacting with the property. So interacting with the case, so number of heart becomes 1, and if it's already alive, you're only simply gonna add that to the associative value, okay, by 1. Okay, cool. Now let's do attack. Okay, attack. It's a little more complex, but not much. But you know what to use. Switch, right? Switch and self. Examine the self right now. If it's alive, okay, you can use a case let, or you can also do it this way. If it's alive, and then you let number of hearts. Okay, if it's alive, you're gonna if number of heart is 1, if the current value is 1, and self equals dead. Okay, and else self. Keep putting this mysterious dot alive. Number of hearts, the current number, right, minus 1. Okay, and lastly, if the case is simply dead, we forgot the last case, which is dead. If it's case dead, okay, just simply break out of it. So when you use a break, means you're just exiting out of the switch statement when you call the break. So you're not going to call anything else. So here we go. We have this. Oops. Right there. Am I making sense to you right now? Okay. So we have a get attacked. Okay. If it's first, we examine the self. If it's alive, all right. If it's 1. Just becomes dead. If it's not, if it's 2 or 3 or more, or if it's alive, then yeah, if it's besides that, the current heart minus 1. Okay, I should be like, it should be greater than, I should be not equals, I think it should be greater than 0. So it could be like, if it's minus 1, it should not happen. If it's minus 5, yeah, it should be dead. It should be dead. It should not be when it's alive, you should not have -5, but just in case. Here we go. That's it. So now let's play around with the game. So there's no UI for this, but if I were to make a UI, that's pretty much all you need to do. But you got the logic here. That's the logic when you're making a game. That's more important than making simple UI, because you want to make your code more scalable. UI, it's all based upon when you press this, something happens. If you press this, something happens. So something happens, that part is more important than making simple UI. So first of all, let's start with dead. And if you increase a heart, now it's going to be alive. Okay, on the right side, it's going to be alive with 1 heart. And if you increase a heart again, okay, if you're increasing a heart again, you're going to be alive too. All right, awesome. And if you get attacked, let's see what happens. State.attacked can be 1 and then becomes dead. How is that? It's pretty cool stuff, right? That's it. You'll learn how to design a game using protocol-oriented Enum. And if you are thinking of making a game, always think of, hey, how can I really apply protocol with Enum? Well, in this case, you don't really need protocol in this case, right? You don't really need the lifespan protocol in order to do that, right? We can just simply make functions, but protocol does provide a blueprint. You don't need to use protocol-oriented Enum all the time, but I just want to show you that you could do it this way. So when somebody reads that protocol, you can clearly tell, okay, this thing contains increase hard, this thing contains get attacked. It kind of provides a little shorter way, instead of reading the entire function, entire enum, you can kind of take a look at what this thing would look like. It kind of tells you what the blueprint of that. So it might be increase your readability. It's all up to you, but if I were you, I'll probably use protocol because it simply tells what kind of stuff I'm gonna see throughout the entire enum code. It just tells you right there. Okay, and lastly, we're gonna have a little more fun. We're gonna have a little taste to custom operators. Custom operators are nothing. These are symbols, right? These are like these are operators, right? We're gonna talk about how to create our custom operators for enums. We're gonna own custom operators. So let's say we have a game action. We have a start, pause, and stop and restart. Okay, and then we want to compare it. Let's say we have a game. We want to do something like this. Okay, we want to do something like this. If it's game stop equals game stop, it doesn't work right now. Okay, but we're gonna make a symbol. We're gonna make a function for this symbol. Again, operators are nothing more than functions. Okay, this is how you're gonna do it. So first of all, I'm just gonna copy this. I don't think. So let's say function right there. Okay, this is a function. This is a custom operator right away. I'm going to talk more about it in chapter 10, but just wanted to give you a little taste about this. So let's say we have a left-hand side, which is the left-hand side here. On the right-hand side, there's a game action. So you need to compare with the game action versus game action. And it's going to return Boolean, so if it's true or false, okay? So we're going to use a switch statement. So if a left-hand side and a right-hand side, case, start, if they are equal, pause, stop. If they are equal, we're using switch statement for, I guess, for right here, and then if it's equal, it returns true. But also it can be just associate type as well. For restart, if it's restart delay the same, return delay. If it's equal, it means true, right? You can know this means true. This means true. Oh, never mind. No, never mind. You have to do this way, right? You don't have to say if blah blah blah. You can just simply call it like this way. Okay, if it's 3, it's gonna return true. If it's 3, 4, it's gonna return false. And default, rest, anything else, return false. So for example, you can do game action, restart, delay 10. Game action, delay 10. It's gonna return true on the right side, right there. How amazing is that? This is a custom operator. I'm giving you a little taste to it. You're gonna learn how to do it. There's a lot more going on in the later chapters, so you will appreciate what custom operator allow you to do it. And let's learn more in the next chapter. I know you're very excited about this. This is something I when I first saw it, I was like, wow, this is amazing. So just that's part of it. That's besides the main point of this lesson. But anyway, all I wanted to say was you could provide a blueprint so it increases readability, because you don't have to read the entire enum, because you know what the enum would do by just taking a look at what lifespan protocol would look like. Okay, so that's how you become a better programmer, in my opinion. So see you guys in the next lesson. Keep learning. If you have any questions, comment down below. I'll be right there, no matter what. Going through the summer, I'll be right there for you guys, no matter what. So see you guys. Bye bye. Boom. Some may feel uncomfortable with the fact that we've been using enums excessively. That's good, because you're now challenged to think in different ways. Most developers tend to go with structured classes. That's why it must be uncomfortable for some of you guys. However, you may be right. You don't even need to use enum all the time. And just like protocol, it could be an overkill for certain implementation. For example, in the next lesson, you will learn how to use recursive enums to add and multiply numbers. And afterward, I will show you more better ways, more zen ways to solve that particular problem. Just like the protocol, enums are not the ultimate savior. You have to learn and study to a point where you can calculate all the trade-offs and benefits that come along when you decide to go with certain implementation. In this course, we are learning that. See you in the next lesson.